Welcome back to the History of Automation podcast and show. My name is Shawn Tierney, and along with my co-hosts Jeremy and Gary, we'd like to ask you before we get into the show if you've been enjoying these episodes and if you think we should continue it in 2026. Now, it's quite a time investment every Sunday to meet with people and to recruit people and to interview them and then to edit and upload it. And so we want to make sure that if we're doing this, that there's an audience out there who wants to hear this every couple of weeks. And so we're asking you to place your votes. You go to givesendgo.com/automation museum, and you can make a donation like $5, $10, or $20 if you'd like to see us continue in 2026. And if we get no votes, that's okay too, right? Maybe the timing isn't right for an automation museum. But if you're enjoying the interviews we're doing with some of the legends in our industry about some of the products, the creation of some of the products that we all use and love on a daily basis, well then please consider going over to givesendgo.com/automation museum and help us raise enough funds to get this nonprofit off the ground. And either way, I want to wish you all good health and happiness. And now let's go ahead and get into this week's episode of The History of Automation. Hey everybody, welcome back to the History and Automation podcast. My name is Shawn Tierney, and I'm joined again this week by my two co-hosts, Jeremy Pollard and Gary Wilkinson, and I'll just let them say hi real quick. Go ahead, Jeremy, you're next on the clock of the faces here.
I'm on the top left corner, so I don't know what that means for you, but good afternoon and good morning and good evening, fellow automation people. Thank you for tuning in. It's appreciated.
And Gary, go ahead and say hi.
It's great to be here, and I'm Gary Wilkinson, formerly Triconics, and just interested in automation history. So I'll be asking questions today.
And I probably should have mentioned you guys are starting to see some stuff show up in here. It's here and there I'll be in the garage and I'll put something up. I put a couple of PLC2s up in honor of our guest, who is Cindy. Is it Hollenbeck?
Yes.
Okay. And Cindy has been in the automation area for many years. And so we wanted to ask her about her experience in the early days of automations, the 80s and 90s, talk about the products and where she thinks, how they evolved and just anything that she can share with us, because she's been an integral part of the industry for many, many years. And I know even Jeremy actually worked with Cindy for a while. So we're looking forward to hearing all those stories. But I think we should start off by Cindy, if you could just tell us a little bit about your career. I mean, tell us where you are now, what you do now, but then tell us about your career, how you got started, and we can jump right into some of that old stuff you used to use.
Okay. So when I got out of college, I went to work for Allen Bradley, which is obviously now Rockwell. And I was in the marketing department for the PLC group. And my charge there was to specify the earlier PLC2 processors. I actually launched the PLC 230, the T3 terminal, those kind of products. And then met my husband, Dick, at Allen Bradley. He was the process engineering specialist or process control specialist for the sales division. He got transferred down to Houston. So at that point, I left Allen Bradley and did some other things relating to oil field equipment, sizing valves and all that kind of thing. And then in 1983, Dick started Teledenken Resources, which was a software company for PLC support. And after about a year and a half, I joined him. And we've been doing that ever since. We changed the name of the company in 1993 to Soft PLC Corporation, and that's what we are today. And so we focus on PC-based controls, I/O, and supporting products along that line. Anything else you want to know?
I have to mention too that one of the very first products that Teledenken put out, beside the O&E, which is communication board, was a program called SoftWires. And it was simulation software on a PC where you could run your PLC program within the PC. So you can do some testing, so you could toggle bits and so on and so forth and check out your code. And that's what caught my attention back in 1986 or 7. John Nanowski was the guy's name that actually dragged me into the booth at a IPC show in Detroit and talked my ear off. But I got to tell you, it was one of those moments which was life-changing because of the fact that I represented Teledenken in Canada for some time before I went down to Houston to work with them. So it was that moment in time which changed everything for me, if you will. So,
Yeah.
which is,
Yeah.
I guess I need to say thank you, Cindy.
Well, you're welcome. It's fun working with you. So,
One of the things I want to bring up before we sort of get into the software part of things is the first project I worked on, and I believe it was 1980, 81, and it was a lumber sorter, trimmer sorter, and it was a PLC 230, and we had to develop an HMI out of toggle switches for it, and we had to write the software on drafting sheets, like like the A1, like the big sheets, and I was writing code and documenting it, but I had no way to test it until it was all done. And that's an important part to remember, because as we move through the PC-based software era, and with softwares, you could create a piece of code, test it, put it aside, and go on to the next level of functionality, if you will. So in the beginning, we had to create the control strategy, implement the control strategy as a whole, and then troubleshoot the control strategy all at once, which could lead to all kinds of issues. So, from that perspective, Teledenken Resources in 1983, along with, I don't know, maybe 12 other companies in the 80s, started developing and marketing PC-based PLC programming software for engineering people and for maintenance electricians and stuff. Changed the whole game, in my perspective.
yeah, it was funny because the first product we actually did, you mentioned, was O&E, and that evolved from some Radio Shack TRS-80 code that Dick had written to tie a data highway to a Radio Shack computer for a water treatment monitoring project. And the PCs at that time were so brain dead. We actually ported that to a coprocessor, and we sold the drivers on a coprocessor because that's the only way we could get the throughput that we needed and the memory. And a company called US Data had a product called Factory Link, and they were embedding our drivers on that coprocessor into their product. And then Shell came to us and said, we want to plot our ladder diagrams. Because at the time there was no PC software, and PCs were still fairly new. And so we created a documentation product called TopDoc, which allowed them to plot the D-size drawings of their ladder logic. And then on our own, we said, hey, why don't we just go ahead and do the editing? And we did all the reverse engineering. And then Frito-Lay actually came to us and asked us to do the emulation. And that's what started us on that path.
Wow.
So they actually simulated all of their stuff. They would tie all these computers together. We actually had a hook in for SCADA, so you could also simulate or test your SCADA package against the simulated PLC. So they would set up a complete testing center for, a multi-PLC line using the Softwires product.
Mm-hmm. It was, at the end of the day, simulation was something that it's not like it is today. It was so leading edge, and you didn't have to have an $8,000 to $10,000 CPU hanging around, to do any code testing. And trying to do that on a T3, well, Shawnee, it's like crazy, just crazy stuff.
Yep. And then Allen Bradley at the time didn't have PC software, so they came to us in the late 80s and asked us to do a PLC3 package, and they actually sold that, which was the original 6200 PLC3 software, was actually our product, private labeled.
Nice.
And then when they came out with their own software, we're like, we got to do something different. And that's when we took the emulator and built it with a real-time operating system and created the PC-based PLC called Soft PLC, which was a PLC-5 clone, basically. And at that time, that's, late 80s, early 90s, industrial computers were, $6,000 to $10,000. They were, really expensive. So it was not really feasible to compete against a PLC, because the PLC vendors had a strategy, which was 80% of the control system cost is the I/O. So they made the CPUs inexpensive to keep the I/O money coming in. So, you could buy a CPU for less than an analog card, which made no sense because the CPU is the brains, right?
Right.
So the PC-based control market took a long time to get going because it took the computer prices to come down, and the I/O systems like DeviceNet and Profibus and the open architecture movement in the early 90s that made the PC control feasible, because you weren't tied into really expensive I/O interfaces. You weren't tied into the same kind of computers. You could get smaller computers, and the memory was increased so you could run the software without needing extra cards and coprocessors and all that kind of stuff.
In that first iteration, Cindy, in the early to mid 90s, was the documentation on board the CPU?
No,
Just
it
didn't
was
have
not.
enough room?
Yeah, you didn't have enough room. It took till like the mid 90s before you could have enough room, because you weren't in the DOS limitations, and and the memory managers became better, and so you didn't need to worry about that at that point. Yeah.
Cool.
Yep.
Memory, I mean, back in the 286, 386 days of expanded and extended and QEMM and all kinds of other memory managers and stuff, I'm surprised we still have hair.
Hey,
Well,
At
speak
least
for
some of us
yourself.
do, right?
yeah,
But
geez, Gary, what happened to you?
Happened to me. I'm
You
still
still
here.
have hair.
you have hair.
What retirement will do for you, right?
This is true.
Amazing.
Mm-hmm.
So, yeah, Cindy, it's just great to have you here. We're kind of a history channel, but we're also just as interested in what's going on in today. And I sent my colleagues a help wanted ad for a company called Triconics, and we would like someone who was knowledgeable about Windows-based programming and PLCs, and to do some testing, an entry-level job. And we just don't see those want ads anymore. It was on LinkedIn, of course, and that was amazing. So I guess one of my interests is what the changes are, what the challenges were. We kind of know what they were at 85 and 95, and now what's the state of personnel and with AI and all that sort of thing. Gosh, that's a large question, larger than what are your
I'm not
thoughts?
sure what to answer
What are your
there.
thoughts on what's going on today? And where can we find a job in automation? What are they doing without the people? Experienced veterans.
Well, there are still people. I mean, that there's people that were working at an end user and want to get out of that environment, and that sort of thing. And there's nowadays, the controllers are different. You can program them with languages that the kids understand. That you don't necessarily have to go with the older ladder logic. You can, program in C. You can program in Visual Basic, and there's all kinds of opportunities to move forward to the stuff the kids are learning in school now, and that they're interested in. But I see AI, becoming the way to program. You can just tell it, write me a program to do this, and it'll do it. I mean, we're using that to generate our base code. There's no reason why we can't use it for automation.
Mm-hmm.
And how about the testing portion of the AI generates the code and you're going to, you're the intermediaries. What is the testing phase like for AI code?
I'm not sure what other people are doing, but in our environment, you can run the program on a computer, so you don't need to worry about the cost of setting up anything, and you can test it interactively. A lot of the controllers nowadays have single stepping or the emulators built right in.
Mm-hmm.
So it's kind of an integrated environment, just like we have with software development. You can compile. You're not really compiling the code, but you can write the code and test it as you're doing it, by bouncing it off of a web page or a simulated system like an HMI, or something like that. It's pretty easy to whip together an HMI to test your controller code.
Mm-hmm.
Do you find the HMI interface is more web-based rather than, graphic code and drivers and all that kind of crap? I hear Python's becoming a language that people want to use.
We're finding OEMs are going that way more because they can save so much money.
Mm-hmm.
Why buy a software license? Most of the software vendors now, they're going to this subscription-based model,
Mm-hmm.
where you don't just buy it once and then use it. You're paying on a monthly basis, and customers don't like that,
No.
especially OEMs. And so we're finding more and more of our OEMs are using our built-in web server in our controller, for example, and just running on a browser.
Mm-hmm.
And letting the controller house the operator interface. Now, you're not going to do that for a big SCADA system with a lot of data acquisition and that sort of thing, but just for an HMI, that's the way to go. Yes.
Yeah, I think it's funny to listen to you guys talk, because it seems like the more things change, the less they change, right? The more they stay the same. And so if we go back 40 years, your high volume OEMs, they wanted to use a custom circuit board or something that was very inexpensive, no license thing that they could crank out. And typically those systems were much, the control scheme in them was much simpler, right? Like an industrial washing machine, right? But then you start getting into the higher end products, and the people in the plant wanted something they could work on. They wanted something they could change. They wanted something that their guys would be able to understand. And we talked about the Modicon 084 and how ladder logic really fit into what GM was looking for, right? They wanted something the guys could understand. They didn't like the PDQ2 as much because it programmed their mnemonics. It was more like computer code, machine language. And so, and that's still there today. I still see, you constantly see people trying to get OS, I'm sorry, the Raspberry Pis in and the Arduinos in.
Arduinos.
Yeah,
Mhm.
but at the end of the day, the guy who's maintaining a staff of 5 or 10, electricians or technicians, he wants something that if they can't figure it out, they can call somebody and get an answer to. And I think that's where, these vendors, right? People come to the vendor, they buy, $250,000 worth of IO and PLCs and HMIs, and they know they're going to get support, right? I haven't met a vendor yet, and I've talked to a lot of them over the years that wouldn't stand behind an order like that, right? And I think the custom, this always goes back to the custom breadboard or the custom code, right? People want a vendor like Soft PLC or like, another company that's going to stand behind what they sell. And I think that's why we don't see as many of these JavaScript or Python or
Mm-hmm.
Raspberry Pi type installations, just like we didn't see a lot of people. I mean, I go back to the early 90s, the guys at Leviton. You guys know Leviton, they make duplex receptacles, they make light switches, they make all kinds of electrical products. I mean, they're in directly to some IO, and that was great, right? That was great, but it wasn't something they wanted on the plant floor. They would, something that was going to run 24/7, 365. So,
Mm-hmm.
I mean, do you guys think I'm wrong? Or, I mean, I still see
No.
that same, it's why people don't make their own cars today, right? People still go to one of the big manufacturers, most of us, and buy a car that has a warranty not that we can't build our own cars, but who wants to? Am I wrong?
What do you think, Cindy?
Well, no, I think you're right. But I think society is becoming more disposable. And so, as costs have come down, you don't need to fix it. You just, as long as it runs, it's okay. If it breaks and it's $200, I can throw it out and put a new one in. Do I really need to mess with it? Once that machine is working, uh, you know, it's like today we get calls from people with PLC2s all the time. We're the only PLC2 solution left on the world. And so people will call us and say, hey, my battery died. I lost the program. What do I do? I open the cabinet and there's this thing there that I didn't even know was in there. And so, we're like, well, yeah, we can get you going and you can keep using that. But why would you want to do that when you could buy this thing for $500 and replace it and still leave all your wiring and everything else? So, and I see that, like I said, with our OEMs, it's like, they want to buy a low cost system. The customer doesn't really know what's in the box. If the box breaks, the OEM warrants it, or the customer will go buy another one from some other OEM. That's not true of a system in a plant running a line, but what you got to look at the market when you answer your question. The plants still want to be able to maintain their systems. They want to be able to change them, add features without having to call back to the original integrator or OEM. And so they still want the support and the structure and the big company that has the support for them.
Yeah. I think downtime too is a part of it. What's downtime cost, right? Would you risk downtime of, I don't know, $10,000 an hour on a $200 Raspberry Pi? So, but if you're R&D, or if you get a little, a small system, then why not? Why not experiment with other stuff? But like the stuff you guys make, Cindy, is tried and true. It's been on the market for decades. But a lot of these new things that come out, it's like, are they really tested? Have they been tested in the field? They look shiny in a brochure, but do they have that? Do they have that? That history of being reliable?
Right.
And it makes a lot of sense if you're talking about a $200 control system for a vending machine.
Yeah, exactly.
Right? Plug and play, get out, fix it up. But when you're in a process or machine controlled environment, it typically will be a little bit larger than a $200 or $300 piece of hardware. There's a lot more supporting cast that surround it, and they need to have a periscope into what's going on when the process fails, and you need that information coming back. And to have that information coming back, do you need a certain level of intelligence in the CPU or in the system to give you that information to make those decisions that that need to be made at 3:00 in the morning? Yeah. So I think it's maybe a catch-22 depending upon the application and whether or not it needs to be line supported versus swap out supported. There's a line there somewhere, but I mean, everything and everybody and everything's different.
Yeah, it is a factor of what does it cost to not be able to run that system.
Yeah.
And then how complicated is it?
Mm-hmm.
Yeah. If the pump machine doesn't work, who cares? But if the the widget maker that's making 100,000 pieces a day doesn't work, that's a big deal. Right? Yeah.
Yeah, there's a lot to be said for what the application is and what the financial repercussions are of it not doing or producing what it's supposed to do. And if you've got a dial table with 12 stations and one station constantly goes down, but all 12 are being controlled by the same control strategy, then your focus is on the station, and it's probably a proc switch, or it's probably this or probably that was just bad design. But in order to figure that out, you need to be able to get into the guts of the system and try to monitor and figure stuff out. And you need those tools to be able to do that. And I don't think Raspberry Pi and Python and any abstract type of software platform will allow you to do that. And that's where you have to get the guy who developed it out of bed at 3:00 in the morning and say, hey, WTF is going on?
And a lot of those systems don't have the built-in troubleshooting tools or I don't know what you want to call it, expertise of the industry of what's expected of a controller. You know, you can write a program to do something, but that doesn't mean it's doing it the right way. You know, it might be accomplishing the tasks, but it doesn't have the infrastructure, the communications that you need, the built-in logging of, you know, what's going on in the system that allows you to go back in and fix it. And you know, we've got, you know, I don't know, 30 years of code in our controllers to do that.
No, I want to ask you. Go ahead.
Well, I was just going to say this. I worked on a project for DNA testing, and it was 2 dial tables, and I was tasked with controlling and pouching the swabs that come out of the dial tables, if you will. And the system it was interfacing with was a Beckhoff PC-based control system, whereby we had absolutely zero visibility into this thing. And 10, 11, 12, everything was fine. 13 didn't work because the signal to indicate for me to tell it, because there was some handshaking that went back, I didn't get the handshake. And then I'd get the handshake midstream. It's like, so I had to put troubleshooting code in the PLC and to try to figure out what was going on. And that's how I discovered that the handshaking was coming in inconsistently. So think of a 3 a.m. sort of deal. And this is not a bounce on Beckhoff. It's just, that's what that's what was being used. But we had no tools. And the code was custom, which you can do in a PC-based control system.
Hey guys, I'm just breaking in here. I hope you're enjoying this week's show. I just wanted to remind you that we're asking you to vote with your wallets. If you want to see us keep giving up our Sundays to do this, we'd be happy to. We love doing it. We got some great people lined up for 2026. But we're going to need you to vote to let us know that you want us to do that. And the way you vote is you go to givesendgo.com/automation museum and you make a $5, $10, or $20 donation. If we can get up to, I think it's like $800 to actually file the paperwork for the nonprofit, we'll try to do it ourselves and save money if that's all we can raise. Then yeah, we'll keep it going in 2026. We actually have some great guests lined up for the show, but we need you to vote. We need you to vote and let us know you want us to continue doing it. And because we love doing it, but we just want to make sure we're spending our time someplace where people think it's valuable. So again, if you want to see the History of Automation podcast and show, continue to go. If you'd like to see the Automation Museum become a reality, please visit givesendgo.com/automation museum and place your vote with a $5, $10, or $20 donation. And we appreciate it. We appreciate it. And again, we'll continue to bring you this show if you think this is something valuable. In any case, I do want to wish you all good health and happiness. And now we'll return to the rest of this week's episode of the History of Automation podcast and show.
We had absolutely no access to the source code. We had to get the vendor of the machine up to Canada and spend a couple of days organizing it. We turned cycle time down from 7.5, 8 seconds down to 2 seconds, 1 3/4 seconds, and with consistency, because there were bugs, and yes, they were fixed, but they couldn't test their stuff either. So I mean, the only way it could be tested would be to have everything together. But again, even if we had the tools to look at it and say, I know that I'm getting this handshake too late or too early, I couldn't have done dick with it anyway. Because again, just not having the tools. Again, that whole 3 o'clock in the morning thing. Who's going to be in there troubleshooting C code, type thing. So anyway, okay, thanks.
No, and I had a question for Jeremy and for Cindy too. If we go back, 30, 40 years, there wasn't easy to program, right? We're talking the terminals, right? And terminals with membrane keypads and a lot of those especially PLC Pro 2 programs I've seen had very small programs, like 100 rungs. I've seen some under 50 rungs. And I'm not saying that they weren't worth the investment. I mean, these were systems that needed to be automated. You didn't want to have somebody sitting there pressing buttons all day long, right? So they were value to the user. But have you seen that too, or were you seeing a lot of 2,000 plus rung programs back in that era?
Defer to Cindy.
Well, I would say that there were a lot of those, for the mini PLC2s and maybe the earlier ones, but we've seen, the 1774s with hundreds of rungs. I know I've converted some PLC 230 programs that were in the thousands.
Oh.
I mean, they had a memory limit in the PLC, and it was so hard to program those things because, well, until the 230 and the 215, there really wasn't much of an instruction set, right? You had 3-digit math, BCD, it was, I mean, one of the things Dick wrote when he was at Allen Bradley was a PID subroutine for a PLC 230 using 6-digit math. And oh my gosh, this is so convoluted to try and make this work. But, that was what you had to do back then. But there were some big ones, and they did the job. There wasn't as much need for data as there is, or not need, demand. Now they want the PLCs to collect more information. There's more interconnectivity than there was back then. So that there's a lot of the programs now are bigger because they're doing more than just control.
Diagnostics is probably a really big thing too.
Yeah.
When GM created I can't remember exactly what it was. It was in the Oshawa plant, in the car plant, so it could have been a lay down side frame line with 50, 60 stations, and it was all being controlled by a PLC3 with redundancy. And the control code was like, the numbers are what the numbers are, but let's say it's 1,000 rungs for the code and 11,000 rungs for diagnostics. Wow. So and they reported all of the fault issues using a printer through a VAX mini computer. Today, it's right here. You can get it right on your phone. It's crazy.
Yep.
Yeah. Gary, I'd like you to jump in here because you got in this industry, your second career in the mid 90s, and so from your perspective, right? What were you seeing, and how can we compare that to maybe some questions we can ask Cindy?
So certainly worked in technology or the military end in the 80s, and it wasn't until the mid 90s I joined a company called Triconics, and yes, it was a PLC, but it was in this niche at the time, largely created by Triconics, or certainly was part of it, called the safety systems. So everything we did was safety programming, safety PLC, everything that just was embedded in every product we made, and actually, more importantly, the culture of Triconics. And competitors soon found this market, these two small companies that I worked with called Triconics and Wonderware. Hey, they're both number one. The markets they pretty much created. How did we miss that? That's actually that's what I believe is, not the book, but certainly the history of sorts. So that I'm just thinking of the changes from 1995 to today. and the engineers at Triconics and Wonderware who I started in the mid '80s, and I still know them. They're looking at the things they created, and they're still in the plants. They're still working, and we thought, well, shouldn't there? Maybe we should apply a warranty to one of these things. But it's the reality. But actually, Shawn, just I had a question. I assume that Cindy and you are still probably the only two in the call who are still seeing resumes, shall I say? So, Cindy, I don't know if you know I have a current gig at the university where I teach business communications. I think that's where they assign recovering engineers like myself. I used to teach engineering. I teach business communications, known as soft skills. But I mentor young engineers, and of course, they give me their resumes. And I guess my question is, Shawn and Cindy, what will you be looking for in a resume from a college grad today? If you were hiring, what would specifically you would advise?
Well, we're a manufacturer, so when we are hiring an engineer, it's a software engineer. And so we're
Mm-hmm.
looking for someone who, is a good programmer and, uses AI tools, frankly, because the last couple of people we've hired, that's what we've been doing is, a meld of skills of AI and C code, basically. Uh, we do some other language stuff too, but the core of our system is still C++. And we teach them the industry as opposed to asking them to know the industry, which is different than like a support guy. We're looking for somebody who's got the field experience.
Yeah.
So we're looking for an older person, for technical support. Yeah, like Jeremy.
Right. That's another topic that I think a couple of us saw on LinkedIn. Who was that message from Jeremy on LinkedIn? But gosh, it resonated, someone in 50s, 60s, or 70s. And hey, I still want to work. Where can I go? And that was really just something to look over. It was a great answer, Cindy. So I can send 1,500 resumes your way and just put your maybe I'll get your site
They got to
permission
live
for
in
that.
Texas, though.
There you go. Well, what about remote work?
No, we don't do that.
Of course, of course. Shawn, what are your thoughts on what would you be looking for in a resume these days?
Well, I would tell everybody who's not retired, right? If you're not retired, whether you just got out of school or you're 40, 50, whatever, always try to stay up on the latest technology. For me, being a self-employed instructor and content
Where'd you go?
out their products.
There you go.
Whoops, am I here?
Yeah,
So,
you just pause for a bit.
so being self-employed, I do that by having vendors come on my show and tell me about their products. But the other thing
Mhm.
too is like, if today, not talking about the history, but today, you should be playing with the AI because AI does a lot of good things and it makes a lot of mistakes. I asked it to sort a tag table for me. I took the tag table, put it into my panel view, and I realized that it had changed a bunch of the values of my tags. It renamed tags. And I could see in my brain that when it wrote the code to sort my tag table, it actually wrote the code incorrectly. I was avoiding doing this and, I didn't want to break out, a macro in Excel and do it myself. So I wanted AI to do it, but it started relabeling everything instead of, it was relabeling it relay 1, relay 2, relay 3. There was no relay in my entire tag table. It just came up with this automatically. It hallucinated. So you can save a lot of time. Sometimes AI is faster than a search engine. Like if you're searching and you're struggling to find an answer, try one of these AIs. Try a ChatGPT, a Grok, and there's so many more, Geminis and all these others. Try them. And I found that sometimes when I can't find something in a search, they're helpful. So always try new things. Like I remember when the CD-ROM came out, like I was one of the first people I knew who had a CD-ROM because it was brand new technology. The other thing was Rockwell was putting all their manuals on CD. So I still have that CD collection of manuals, hundreds, thousands of Rockwell manuals on CD on the data disk. And I still
Yeah.
refer back to that today, you know, because, you know, if I'm trying to look at something old, you know, it's so hard, you know, and I never understand why vendors do this. I always joke with them. I'm like, my grandson has like a spare USB stick that if you're a multi-billion-dollar corporation can't keep those, you know, 2 megabytes of PDFs on your server, you can use his spare USB stick. Why do they take these old manuals off their web servers? I don't know. It cannot be space because my grandkids have more extra space lying around than they would need. So, like, why would you remove a PLC 2 manual or a PLC 5 manual or a Ready Panel or data line? It's like there's no reason to. The tiny files. But I'll get off my soapbox. But yeah, I would just say, you know, you want to look at people. We once hired a guy smart kid, who had a computer degree, right? Computer engineering degree. And we're like, look, we're in the middle of training people on PLCs. Here's what we want you to do. We have some other PCs out in the other room. We need you to just format them. They kind of got messed up. Just format them, reinstall Windows, and then we'll ghost them. And he's like, I don't know how to format a computer, install an operating system. And I'm like, you have a computer degree. How could you? So you don't want to be that guy, right? You want to have the practical, not just the knowledge. You want to have the practical. And that's my advice to everybody. Yeah.
Okay.
That's a good point, Shawn, because you know these guys, they learn the programming side, but they don't learn the hardware side or the setup, the IT side. Yeah.
And
Yeah, a lot
networking
of
is
these
really
kids
important.
have never seen an Ethernet cable. They literally, you know, I've talked to so many people, and it's like the kids coming out of school, they think everything's Wi-Fi. It's like they've never seen a physical cable. You know, I love those. There's a lot of people on YouTube. They're setting up home labs so they can play with servers. They can play with cybersecurity, and that's you kind of have to. You know, they used to call it shop in the soil. You got to maintain your own skills. You know, you got to upgrade them yourself.
Yeah,
Cindy,
yes.
1983.
Yes.
The company gets started. Shell comes to your doorstep. You're creating PLC programming software. How hard was it to penetrate a market that just loved the T3 and the T50?
I don't know that market.
T50 was a computer.
But actually, the PLC2 actually was pretty easy to start selling because there was nothing else out there. You know, there was us and ICOM and a couple other companies, but the Allen distributors didn't have a block on selling a third-party product like that. And so they embraced it, and it was relatively easy to get out there. And I still remember we ran this ad that had my 2-year-old son in it, standing on top of a T3 holding a disc, a 5.5 or 5.25 inch disc. And I talk to magazine guys now still, and they're like, I remember that ad, you know.
Nice.
Way back when. But you know,
hope Darren's getting royalties from it.
No, he's not. But you know, it's harder now. It's harder to fight when the big boys have products that are similar to yours because they're right there at the point of sale. But back then it was pretty easy actually.
Good.
You know, and the internet didn't exist, so people read magazines, so they saw your ads. You know, you could mail a postcard deck out back then, you know, and you would get 600 or 700 responses to a postcard in a deck of 40, 50 cards because there was no other way for people to get information. You know, it's just not like today, right?
No.
Now it's
and part of the reason
online.
that what we're doing, Cindy, is for stories like that to make people understand we came from somewhere, and there are people out there that created something out of nothing. You know, and you and Dick were part of that. Steve Rubin was part of that. Dennis Morin was part of that. You know, Bill Gates was part of that, if you will, because the youngsters, I think they just take for granted what the hell we've got now because it's so easy. Try to print out a freaking ladder diagram on a Silent 700 serial printer at 300 baud with thermal paper. Go ahead.
Don't
Yeah,
miss
I like to
thermal
tell
paper.
I like to tell my kids about my high school basic programming class on the paper tapes, you know, the 1 inch
Yep.
circular paper tapes. It's
Yeah,
like,
the
and they
teletype
look at
stuff.
me like it's just like, you know, what are you talking about?
I know. Nobody knows what a telex machine is.
Yeah.
Oh my
For
God.
good reason.
This is true.
Ah,
Facts, baby. Just the facts. But no
No
thermal paper.
kidding.
Oy, oy.
Well,
It was like an
it's been an
accordion.
interesting. Hmm?
The thermal paper on the fax machines, it was like an accordion. It would all roll up. It was
Yeah. We used I wrote a Corning in Toronto developed the mechanics for a packaging line. So it was a box former, and they wanted to do it for 50 or 60 different product types. So everything moved and did, that's all this kind of stuff. And so we formed the boxes and glued them, and then they were manually packed, and then they were sealed and palletized and all that stuff afterwards. And it was a PLC3 program that I had written for all of this, and I can't remember where the heck I was going with this. I honestly can't.
PLC3.
It's like what were we talking about?
Fax machines and thermal paper.
Oh, thermal paper. Yeah, thermal paper. And so it was about 600, 700, 800 rungs, this program. And I'd started on an Epson wide printer, right, with computer paper with the holes in it.
Yep.
And I'd started at about 10:30 at night, and by 7 o'clock in the morning, it might be done. Until something happens and it starts ripping the holes out of the paper. And
It's
so
one
I
line
had
of ink.
500 rungs on one line. And nowadays it's just, you just don't run into those problems.
No.
Yep.
I mean, but I think it was, I can't remember if it was a parallel printer or a serial printer.
Probably
Parallel back then.
Probably
Yeah.
parallel, you would think, yeah.
You wouldn't want to, that would be even slower.
Oh yeah, I had a Fujitsu, which is really nice, that it was serial.
Yeah.
So, but
Well, I'm looking at
Yeah.
the time here. Let's see if there any final comments or questions, Jeremy or Gary or Cindy.
Cindy, go ahead.
Gary looks like he's going to say something. So.
and I just
No.
I appreciate you being here. Oh my gosh, it's just amazing, and hope you can return sometime for
It's
part
been
2.
fun. Talking about
where in
these old
Texas
days.
Where are you located in Texas?
We're near Austin.
Okay.
Yep,
Mhm.
Central Texas.
And what's the current, well, I guess it's a cable series with Billy Thornton or something like that. And I believe it's
Landman?
yeah,
Landman.
that's it. And,
And that's
of
in
course,
Oklahoma, isn't it?
I think it
I'll
is
watch it.
actually.
okay. For some reason, I thought it was in the basin. I thought it was based in Texas. Okay, that's
It
in
might be.
Oklahoma.
Mhm.
Like and of course, the language that they're using is like, of course, I know what he's saying, and some of the attitudes. Obviously, it's TV. But hey, so this old tech guys can say, hey, well, that's actually the way they do talk, and yeah, that's what a wildcatter does. It's fascinating.
Yep.
That wasn't a question, but that was my comment.
Okay.
Yeah, and I'm still
Yeah.
genuine big believer in the future. I'm in the wrong profession if I'm not as a professor at the university, but
Mhm.
Sure.
yeah, I tell my students if you can spell AI, going to your employer, you're 20, 21 years, you've got that advantage. And I do scenarios now.
Mhm.
Explain AI to a baby boomer, things like that. I just really believe they're bringing tremendous advantages to that. What aren't they bringing to it? Well, how to read a checklist and how to have confidence in the procedures. If I look back at my own career, and I got the question, we're doing a startup to a plant. And through that checklist, have the confidence in that checklist, have the confidence in the procedures and to stop and things like that. I guess that's on-the-job training for our future automation experts. But yeah, thanks to everyone.
Mhm.
Well, yeah, I think people need to, like Shawn was saying, AI is not always right. And so you need to know how to do something yourself so you can check it and just use it as a helper, not as the way to accomplish something. And those skills, the critical thinking skills, that still has to happen. And like I look at if you look at the robot industry, that's completely taken over with AI. But somebody's got to know what the procedure is to do it manually so that you can check it, because that's expensive to make a mistake.
Oh, yeah, absolutely. Well, I wanted to ask you a silly question. How much pushback do you get because you're not IEC 61131?
We have targeted a niche of the people who have older Allen Bradley PLCs, and they have that expertise. And so we don't get as much as we would as if we were targeting, more new applications. We're tending to work on migrations and that existing base, or people who just want to embed a small controller. And I mean, they may not even be using any control language. They may be writing it in C or JavaScript or something like that. But most of our stuff is communication gateways, where the logic is minimal, if at all, or we're doing a migration, and so they're reusing the IT that they developed way back when. So, there's still a lot of old folks out there that know that stuff, and they use it.
Yeah. I mean, I think we've talked about it on the show in other episodes. If you go back to Rockwell's or Allen Bradley's first PLC, the iCubed, right? They called it an XIC and an OTE, and that's why Rockwell still calls it today. Why the standard came out way after, Rockwell had already been selling products for years. And so then I understand why they never saw a need to rename it, a contact and a coil, right? But if you look at a lot of the instructions, even in the PLC 5, a lot of them are compatible with the IEC standard, right? The tons and the TUFs, TOFs, and the counters, count up and count down. So, it's very interesting. I'd love to do just a show just on 61131-3 and or 1131-3 and the standard. But maybe that's for another day.
I believe strongly that Otto Struger had a lot to do with that. He was part of the original committee for IEC. Yeah. And I strongly believe, and based upon conversations that I have had with him, that instruction list was Siemens, right? They wanted instruct because they did a lot of programming in IL. And Ladder was more focused on Rockwell or Allen Bradley at the time with their mnemonics, because they were the global leader at the time in the 90s. The Modicon stuff, and I'm trying to remember where that came in, and I can't.
The telemechanique SFCs.
The what?
The telemechanique SFCs.
Ah, true. Yeah, that started out in Montreal too, right? Grasset.
But that became part of the standard because that was the Modicon input, was the telemechanique side.
Understood. So that's where, the different vendors sort of kind of came in and, okay, yeah, we'll do that. Yeah, we'll do this. And then they put the standard together based upon things that already existed.
Yeah. And then you have structured text, which I think all the young people would like, but it's still deterministic. It's still something you can look at online as it's running. And I'll tell you, some of the new structured text, like from Rockwell and Siemens and some of the other, it's a joy to work with. It's not like the old days, right? But I think still most electricians prefer ladder logic.
No question. Does the structured text editors of today have online real-time syntax checking?
Well,
like if you forget a colon, does it tell you?
Yeah, absolutely. But it's unlike ladder where you're editing a rung, and guys, correct me if I'm getting this wrong, but it's unlike ladder where you're editing a particular rung, right? you're editing it's more like a function block where you're editing a page, right? And then when you test it, right, you can test it, right? But you has to go through a step of checking. So it checks as you're writing, it'll check it. And they'll give you, like, just like in Word, they'll give you like the wavy lines and stuff if you get something wrong. But it won't let you put that new code into run mode if it's wrong, right?
Okay.
Just like you couldn't with Ladder. It wouldn't accept your pending edits if there's an error, right?
Right.
So, but it's all the color coding we have today, just like we expect in Microsoft Word and Visual Basic and C++. It's all the color coding they've added to it and all the intelligence, and just it's a joy to
It's been
work
a while
with.
since I've done any ST work.
Yeah.
Probably 10 years.
I should say not every platform, but most of the platforms.
Yeah, true enough.
Well, Cindy, I want to thank you. Anybody else before we close out the show?
Yep.
Cindy, I want to thank you then for coming on the show and sharing that walk down memory lane with us. Really appreciate that. And if there's anything else you can think of, you want to come back on and talk about, let us know. But we really appreciate your time this Sunday afternoon.
All right. Thanks,
Super Bowl Sunday, I might add.
Go Pats.